And I'm going to welcome you all officially because it's 10 o'clock. So thank you for joining us. Just going through the agenda very, very quickly. So we're going to talk about OEE in general, a bit about the theory, how we calculate it, how we then capture the data that you need to calculate it in AIR, and how to get the most from it by using it as a tool to help improve your productivity. And as I say, at the end, we'll finish on a Q&A. So what is OEE? Everybody has an idea of what OEE is. Most people may already be using it, and we'll do a poll in a minute just to see how many of you might be already using it or measuring it in some form within your business. But it is a powerful KPI because it takes in data from various elements of your process and allows you to uncover losses throughout it. So even the smallest productivity losses. So it's made up of 3 factors. Availability. So this is where we look at the machine or your resources that have been connected, and we're monitoring the status of those machines or resources, and we're looking for any unplanned downtime. So those bigger causes of productivity losses. One click. We then take into account the performance factor, and this is now looking at your jobs and whether or not you're making them within the standard planned cycle times that you've defined for each of those operations. So this is where we start to now come down into those little smaller pieces of time where we might be losing productivity. And of those parts that you're producing, how many of them are good and how many of them are non-conforming? So are you scrapping a lot of parts and producing a lot of waste? So just on that score, I'm going to launch the poll just to see if any of you, let's just have a bit of, while everybody's settling in and joining as well, we'll launch the poll. It'll appear on your screen in a minute just to see how many of you are already measuring OEE in some way. And whilst you're doing that, I'll talk a little bit about the benefits of OEE. So as I mentioned, because we're looking at your resources and your process, so when you're producing parts, we're tackling different areas and we're allowing you to come down into the sort of finer areas of productivity loss so you can look for those improvement opportunities. With that data, we give you lots of KPIs in AIR, as you lots of data sets in AIR, which we'll come to later in part in terms of John's presentation demonstration of the system. But all of that information can then help you feed back and share with your team. And we one of the benefits we think of AIR is that we don't limit the number of people that you give access to the system. So you can present this information to as many people as possible, because one of the best things to do to support continuous improvement is provide the information to as many people as possible, give them visibility, allow them to collaborate with you and help find and come up with those ideas that will make the difference to help you succeed. So let's now go and take a look at each of those individual factors, and we'll start off with availability. I wanted to talk a little bit about machine utilization for a minute, because some of you may already be familiar with our machine monitoring module, but that really is oriented around utilization performance. So how much of my time based in my planned hours was my machine or my resource actually running for? And when it wasn't running, what were the downtime causes? Okay, so we take all of it as unplanned downtime. And that's a really good indicator to get started with, and it gives you an idea of those bigger, as I say, productivity losses that you can start putting some improvement initiatives in to tackle. But with OEE, we look at availability. So we're refining that calculation a little bit further by allowing you to define within the status matrix what is planned downtime. So when the resource on the machine would never going to be able to run because there's an activity ongoing that's going to prevent it from running. So that might be planned maintenance, for example, or it may be, you have an operator that only ever runs that machine and they're on holiday. So that could be considered planned downtime. So as I say, in our matrix, we give you the flexibility to define what those activities are within your organization. And we take that, we remove that from the total planned hours. So when we're calculating the performance in terms of availability of that resource, we're taking into account the refined period of time that it was actually able to run for, and looking at that as a total. So in this case, we're working to, I don't think we put a time on this one, John, but I think we're
No.
working over an 8-hour shift on this
Yeah,
one.
that's correct.
So in this case here, looking at it roughly, we were running for 4 hours of an 8-hour shift, and 2 hours of it was in unplanned downtime. Working through that then, to get our performance factor, we take the amount of time that the machine was actually running for, or resource, in this case our 4 hours, and then we look at how much of that time it was effectively producing parts. So obviously we're not looking at the setup time. So I've started my job, I'm going through a setup phase, and then whilst that operation is in progress, is active, how much through that running time was it actually producing parts based on this planned cycle time? So in this example, I've got a part that is taking an hour to produce, but I'm in that 4-hour period. By the end of it, whether I book it every time I produce the part or I book the full quantity upon completion, I've actually only produced 3 parts out of in that 4-hour period. So effectively, I've only been effective for 3 hours of that potential 4-hour period. Hence, I'm getting a performance factor of 75% for my OEE calculation. We now need to drill down to get to our quality factor. So of those parts that we've booked, how many of them were good and how many of them were non-conforming? So now I'm getting my quality losses. So I've spent an hour producing a part in this example, but it was defective. So I've actually lost another hour's worth of productivity here by producing a non-conforming part. Hence, my quality factor is now showing as 66%. At this point, I'm going to hand over to John because he's going to summarize that all for us on this screen. And I'll click through for you, John, when you're ready.
Okay, thanks. So just to look at the end result of this, our OEE figure. So Jamie's talked about the 3 factors. So in this particular example, I've got my planned hours at the top. We've then taken off our planned downtime and we've ended up with some running hours, and we'll put some numbers on the screen in a second. But then we've looked at, and this second part, the performance, there's 2 ways you can look at this. You can look at it on the volume of parts, or you can look at it on a time basis. If you're in high volume manufacture, so maybe you're producing plastic components or small parts, screws, bolts, fasteners, you may have a very high throughput, in which case the fact that you've made 9,500 parts in the time you should have made 10,000 may be really key to you. In discrete manufacturing, so if you're in lower volume, high quality, longer cycle time parts, then it's quite possible that time is more important to you, because depending on when people book parts, it can be more difficult to get a granular real-time view of OE. So you might want to look at, if I've got 40 hours in a week and the parts I've produced, how much time was I effectively producing? How close to was I the standard time? Because the difference between the standard time and the actual time is going to be the time that you've lost. And then finally, the parts that we've made, have we been wasting time making non-conforming parts? So although this is called overall equipment effectiveness, OEE, essentially it boils down to how much time in that total time you've got on shift are you effective. So if you just move on to the next slide, Jamie. Then we see the numbers come in here. Now Jamie's example had a part with a cycle time of 1 hour. So the end result is that we've made 2 parts. So if you click again, Jamie, please, you'll see our OEE is 33%. We had a 6-hour amount of time that was available because for 2 hours we didn't plan to run the machine. Let's say, as Jamie mentioned, it's planned maintenance. We've produced 2 parts with a standard time of 1 hour in that 6 hours. So we've been effective for 2 hours, or a third of the time. So we would now focus on all of those reasons and those areas why we have a 4-hour difference between the available time and the actual time we are effective, because what we should have done is produce 6 parts. And we have been talking about one particular job here, one particular operation. You imagine this on multiple machines, and also during that 6-hour period, we could have had multiple jobs on this machine, all with different cycle times. So it can get quite a confusing picture unless you can roll it up to something like an OEE metrics, which you can then break down afterwards.
Which you've just summarized for me there, which is perfect. Thank you. So, as John said, you imagine, we've lost that time in that one example, but if you've got multiple resources, hundreds of operations, and obviously with discrete manufacturing, you might have a lot of variety across all of that as well. What we can help you do with our OEE is identify maybe where some jobs are overperforming or underperforming, any resources where you are particularly losing productivity to larger causes of larger downtime reasons, so longer periods of times, maybe you've got backlogs somewhere or a resource is constantly failing. So it's helping you identify those areas which you can focus your efforts on first. Obviously, we have a solution for this. So in terms of Seiki AIR OEE, it's a module, it's a licensed module within the system. It has a dependency upon our machine monitoring module. So you wouldn't require the machine monitoring module to be activated. But then in terms of calculate, so that's obviously for your availability factor. But in terms of getting the performance and quality, we have two options here available to you. So with our WIP booking module, obviously we have a digital work queue, and that comes down from the Seiki scheduler or via an integration with a third-party ERP system to drive that work queue, which has all the standard cycle times defined for each operation. So that's the option one. Alternatively, if you don't want the WIP booking module or you don't have an ERP or scheduling system already, we can do it as a standalone solution with the monitoring module, and we give you the facility to enter part information with the cycle times for each operation. So there's a couple of ways approaching this, but fundamentally the output will be the same in either scenario. You would have access to all the same OEE dashboards and data sets, which we'll have a look at in the demo next. Are you happy to pick up on the demo, John?
Yeah, sure. Yeah. So let me just share a screen. So can you see my OEE screen, Jamie?
We can, thank you, yes.
All right, okay. So just bear with me a second. I just want to change some dates.
So what we're looking at here, just while John's doing that, is we're logged in as an analytics role. So as I say, we can give access, we don't license by resource in there. So you can put this kind of information in the hands of as many people, supervisory team members, management, as you need to. And this data is updating directly from the shop floor as it happens.
Just to clarify there, we don't license by user.
Sorry, I said resource, didn't I?
You did, yes.
Sorry, yes.
Okay. Right, so this is not intended to be a full demonstration of our product, and we would need probably an hour to do that. This is just to show you, because we're focusing on OEE, I'm just going to show you some OEE metrics, and I'm very briefly going to show you how we collect the data. As I say, it's not designed to be a full system presentation, but I'm going to show you two different sets of data. Because I've been booking some data today, but unless you're in a high volume manufacturing industry, looking at real-time OEE doesn't really make a lot of sense. For example, let's say you've got a part on a machine and the cycle time might be 15, 20 minutes. Do you really expect the operator every time the machine makes a component to go and book the part that they've completed? And quite possibly they wouldn't. And you might ask them to book it every hour. You might ask them to book it at a break time. You might ask them to book it at lunchtime. You might ask them to book it at the end of the shift. So when people book data is really important when you're looking at OEE data. If you were in a high volume industry, it's quite likely that we've configured the system to give us an automatic part count. So the system is counting the parts in the background, in which case real OEE is a bit more relevant. But going back to my example previously, let's say you've got some large components on the machine with 4, 5, 6 hour cycle times. So at the end of the day, the operator might not even have completed the first part, in which case there's no point looking at OEE today because you won't have produced anything. So you need to look at it over a couple of days or more likely a week's basis. So I've just gone back to a date in August because I want to look at some data historically, but I'm going to show you the data I've got running today, and then I'll book some data and you'll see how quickly it will change the OEE metrics. So we start with an overview of OEE. We've got 56% is our OEE figure. This is for a day on the 10th of August. We've got 67% availability. So what I've got is shift time here. I've got a number of machines, by the way. I'm reporting on all my CNCs. I've got a number of machines and my total shift time is 76.5 hours. But you can see the available time is 75.46. So I've got something like just under 45 minutes, must be some planned activity like planned downtime. And then during that 75 hours, my machines have run for 50 hours, 40 minutes. And I've got a warning symbol here, and if I hover my mouse, I'm not sure if you can read the text, if it's a little too small, but it tells me I've also got some production time outside of the shift. So I've defined my shift, but maybe someone was working on some overtime, so we're still going to use that production time. It's just warning me that it's been performed outside my shift period. So we take that 50 hours forwards and we look at our performance now. And even before I do that, if I wanted to understand, well, where's that other 20 odd or 25 hours gone? I can see it up here. I've got 25 hours of unplanned downtime, and these are the top 5 reasons. I can drill into that, and maybe if we've got time, we'll look at that. But these are just my top 5. So I had nearly 8 hours with the machine sitting idle because my scheduling wasn't very effective, because we didn't allocate the work correctly to the machine. And I've lost 6 hours with machines sat idle waiting for the first off to come back from quality. So once we're running out of that 50 hours, we were effective for just over 44 hours. So I've got 87% performance, but again, I've got a warning symbol here. And what it tells me if I hover my mouse is one or more of the operations have been performed in less than the standard cycle time. Now, OEE is capped as 100%, and each of the factors are capped as 100%. But what this system is telling me now is that 87% is possibly a little bit artificially high, because you've got some other jobs that have run in less than the cycle time, so they would have a performance factor of above 100%. I'm going to show you how we can look at that in more detail in a moment. But just to be reassured, if every job was done in less than the standard time, clearly you need to review your standard times. This would only show you 100%. But it would give you a message to say it's capped, and if you hover your mouse, it would give you the actual calculated value in the background that isn't being used for the OEE factor, but I might have 105%. But if I'm really getting over 100% performance, then my standard times are too generous. And my quality is 95%. We've made 63 parts, of which 3 were non-conforming. So we want to drill into this data, and there's 2 ways that we can do it really. Firstly, we look at the factors. So we start here, you can see the availability factor. There's the same data we saw before. And I could go into my machine utilization. I'm not going to do it because we deliberately tried to limit this session to half an hour, so that it doesn't take too much time out of your day. But in a wider demonstration, I could actually show you how we can really look at the utilizer. I said I'm not going to do it, and I'm just going to put one graph on the screen just to show you that you can really dive right into the detail here if you wish to. But as this is about OEE, let's stick with that. So if I'm looking at the factors, here's the availability. But now with the performance, I've got a table and it says these are the top 5 worst performing operations today, where at least one part has been booked. So if we've got a job on a machine, it's got a 3-hour cycle time, it's going to be the worst offender because it's going to have 0 performance because we've not produced anything. It will still be used in the calculation for the performance factor because we'll be accruing time, but we won't put it in the top 5 worst offenders here. So you can see some time on these jobs. So you can see, for example, the FMS, the job on the FMS, this works order, an operation number making this part here, which is a clamp. We made 13 parts and it should have taken us 3 hours 54. And I think, I won't say my maths is right because I'm doing this off memory, but I think that equates to an 18-minute cycle time. But actually, we took nearly 7 hours producing it. So we've only got 56.7% performance on that particular machine and that particular operation. If I expand the table, then we see all the bookings, and you'll see at the bottom here that we've got 3 machines or 3 jobs where I've actually booked jobs in less time than I should have done. So this one here on my Seiki machine, it was a job an apprentice was doing. I've been effective for 8 hours, but I booked it in 7:48. So one would assume my science standard time is a bit too generous because I've got 102%. So those figures are slightly compensating for these figures above. We add up the numbers and we get the 44.19 over the 50.45. That's what gives us our performance calculation. And then the quality, we do a similar thing. We show the 5 worst offenders here. So on my HAS, I've got 83.3% because I've had one non-conforming part out of a total of 6 parts. Again, I can expand the table and see everything that's booked. So in total, we had 60 parts we booked, plus we had 3 non-conforming parts. And if I just look at the final way that we could slice and dice the data, we can drill into the factors. I could pick individual machines, by the way, in my selector here. If I don't want to take the group, I can pick any of the individual machines, but I can compare machines. Just going to the next chart. So this is quite interesting. So you see the 3 factors here of OEE, and in the table underneath, I've got my OEE, availability, performance, quality. So if I want to see, well, which is the best performing in terms of OEE, I can just click on the column. And the Seiki is best at 92%, followed by the HAS at 83%. If I want to look at quality issues, then if we do it by quality, then my highest quality is on the Seiki. Well, in fact, I've got a number at 100%. Let's look at the worst ones. So the laser etch hasn't booked any jobs. That's why it's got 0. But of the machines that have booked, the worst in terms of quality is the HAS at 83%, followed by the Makino at 87%. And I can change the time period, and I can change what I'm the chart that I'm looking at and the resources I'm looking at. So what I want to do now is just change the time period. I'm going to go to today. So this is live data. My OEE has actually been going down during this presentation. I set my machines. You can see if we look at the OEE is quite low. My availability is quite low. I've only been running for 12 hours out of 25. I had quite a bit of time. So I tried to make this as real as possible. So I started the jobs. I think I started my shift about 7:30, 7:45. I set some jobs. So we'd expect to have setting time. That is downtime. It doesn't matter whether you plan to set the job or not. In OEE speak, it's still seen as downtime because you tried to minimize that setup, or using something like a multi-pallet machine, reduce it completely. I had some warm-up time on machines as well. But after that, I've got all my machines running. So pretty well all my machines are currently running. In fact, if I just very briefly look at my hand on screen, you'll see here, most of my machines are running now, bar the laser etch, which has got no work. But they've been running during this presentation, but I haven't booked any parts. So my performance is pretty low. Yeah, I'm never going to get any better than 50% because my availability is 50%. But if we just look at that performance factor, and here's the worst offenders. Yeah, you can see. So we've made 1 part on the Mazak in 25 minutes, but so that's obviously a 25-minute cycle time. We're up to 1 hour 6. And on the Makino, we've made 1 part. It should have taken us 30 minutes, 1 hour 6 on that. So what I'm just going to do is switch to a view that the shop floor operator would have. So this shop floor operator can run multiple machines, and what we're looking at is the list of work that we should produce, and this is the job that we're currently running at the top. As I said, this isn't designed to be a full presentation. I want to leave a few minutes for questions at the end. So I'm just going to take those 2 machines. Let me go to my Mazak. Here's my Mazak that's running. Just before I book it, let me just go back to this table. Remember, the Mazak was the worst offender, followed by the Makino. So on the Mazak, I'm going to book another part. So I've just booked 1 part. And on the Makino, this operator can run multiple machines. Busy guy. Run another, book a part on the Makino. If we go back to this screen, and I just need to refresh it. Now you'll see the Mazak and the Makino have dropped down, as in they've improved. They're no longer in my top 5. My performance has gone up to 55%. I can't quite remember what it was before, apologies. And if I say span the table, here's my Mazak and Makino down the bottom. They're at 70% now, so much better. Sorry, here they are at the bottom, 87% at 73%. The Seiki is really not booked any parts at all yet. It's So we've got no affected time, but we've been running for 1 hour 7. So just to finish the demonstration, let's just go to the Morosiki. This is the job we're running. My cycle time is 45 minutes and I've been running for 1 hour 8 minutes. So if I book a part on the Morosiki, and refresh the data, now that Morosiki is no longer at the top because it had 0 performance because it's not booked anything. My Morosiki is here in the middle. As I said, it's not designed to be a full demonstration, and we just wanted to show you how you can see the OEE metrics and how you can take some of the data and do a bit of a deeper dive and have a look at the underlying issues.
Thank
Back
you,
to you,
John.
Jamie.
Thank you. I've just got one more slide then to finish on, and then we'll open the floor to any questions. So, as you've just seen, there's dashboards available directly within AIR that gives you an overview and allows you to drill down into all the data within each of the individual factors and across the resources. But some people talk about, well, what should I be targeting? And there's all talk about things of world-class OEE of 80% and lots of different percentages get thrown around. But I think one of the key things that I would say to take away is that it's actually about finding the most effective use and maximizing the efficiency of your resources, your plant, and your operations so that you can continuously improve upon them rather than setting one fixed target. Every environment is different and you need to get and squeeze as much out of it as you possibly can with what you've got. So it's about having that target that you can keep building and improving upon and having everybody work around and have visibility of. And as John alluded to, we can dip into other areas of the system to drill down even further. So where we've looked at things like those the performance factor, we have planned versus actual KPI reports that allow you to analyze how well you are sticking to your standard times across all works orders for a part, for example. We have non-conforming part reports. You can drill down into the production history of individual parts. And as John showed you, with the utilization data, you can find those bigger causes of productivity loss on your individual machines. So there's a lot of information there that can help you work smarter. Is there anything you wanted to add to that, John, before we open the floor up to questions?
No, can you just go back to the slide with the 2 options, Jamie? Because I'm
Yes,
conscious
absolutely.
that we've got a combination of customers that may
Yes.
already use AIR, customers that don't use AIR, and people that aren't customers at all. So just to explain the 2 options, on the left-hand side, if you use our system to monitor the machines and to book the works orders and operations, what we call WIP booking, that will interface to a third-party system such as a scheduler or an ERP system because we pull all of the demand, all of the works orders and operations, all of the standard times into Seiki AIR so we can validate the data. If you happen to be an AIR monitoring and WIP booking user, you can purchase the OEE license now. You don't need to change any of your process and you will immediately get the data because you're already collecting the data that you need. Option 2, if you're using our machine monitoring or you're interested in our machine monitoring, but you don't initially want the to go to the next step of integrating with your ERP system, possibly you don't have a system to do that, then you can use the AIR monitoring system. It can run standalone. It doesn't need to interface to any other system. But what we require the operator to do then is purely indicate the product they're making. We don't need them to enter a works order number. We're not interested in the actual order numbers. So the data is only available at part level, but they literally enter the part in the operation they're producing, and somebody will have already entered the standard times into the system, but we can do a one-off import just from a simple sort of ERP export or Excel file to populate your standard times on day 1, and then you can keep them up to date from there. Well, I'm just conscious that we had people that might suit immediately option 1, people that could expand their system to include option 2, and people that don't have either. So I just wanted to clarify. Thank you.
That's cool. Thank you. Okay, so on that score then, I'm going to open the floor to any questions that you may have. So if you want to release your microphones or send anything across in the chat, please do so.
you want to put the results of the polls up as well, Jamie?
Yeah,
And
I
display them.
didn't realise I'd sent another poll out actually whilst you were doing your demo.
If you
So
haven't voted in the poll,
it was
then
literally
please do.
50-50.
Really.
Yes.
So 50% people use OEE, 50% don't. It'd be interesting. Maybe if anybody's prepared to shout up, is there anybody that has said they're using OEE that is using calculating or has a system such as this to collect the data? I'm guessing some of you might be doing OEE manually or having to pull data out of different systems and do it in Excel. Is anybody doing the whole thing digitally in the way that we've shown here? Is anybody going to shout yes? Okay. So for
Yes,
those
that's
of you,
why they're here.
excellent. So for the people that are producing OEE, so I presume you've already decided it's a valuable metric, so you may want to talk to us. And for those of you who aren't, we'll obviously be interested to hear if you think it would be beneficial to you.
On the machine tool monitoring, does that communicate with the actual control of the machine, or is it done through sensors on the power usage?
Either or, Steve. So it depends. We've got three methods. So the very simplest method is just that we know it's running or not, and that has a clamp-on sensor onto a three-phase supply, so we know it's drawing current. Option 2 is a little bit more advanced, that we would wire in or we would find outputs from the machine. The best analogy I can give you is if it's got a traffic light signal tower on it, then we'll know it's running. We can generally get an alarm condition, not much else, because the machine doesn't know why it stopped. And the third method is that we actually, if the machine has a network connection, then depending on the machine, there's different software protocols that we use to talk to the machine. So if it's a Heidenhain control, Fanuc control, Siemens control, Mazak machine, DMG Mori machine, we have different software protocols that we can use. Other than the Fanuc one, our understanding is every one of those is chargeable on the machine tool end. So for example, if we're going to use something called MT Connect, which is a standard that a lot of the machine tool companies use, we have a software protocol that reads data via MT Connect, but the option needs to be enabled on the machine, which round numbers tends to be about 850 to £1,000 per machine. It makes no difference from our side which method we use. We have a standard price to connect to read the data from machine, and that's the same whether you use the current sensor, whether you use the digital data, the green light, the red light, or whether we talk to it via software.
Okay, thanks.
Sorry, just another. If we are talking to the machine via software, then we can get additional data. We don't pull a load of data that we really can't do anything with because we don't utilize the data. But the additional data we pick up tends to be things like feed and speed override and alarm conditions. So within the running time of the machine that we're using in our OEE, you can actually see that 5% of the time my machine was running at reduced feed because the operators turned the feed override down, for example.
Okay.
Anyone? Any other questions? Jamie and I are happy to stay on for a little bit. If anybody does want to have a longer conversation, we can probably do till 11:45 or just after. But if anyone else has got any questions, please, yeah, pipe up.
I think just looking at some of the feedback as well, I think in terms of what people would want to use OEE for, I think coming through is to improve and review standard times. So obviously we can do that. An interesting one to produce more accurate quotations.
Yeah.
That's a good point. And particularly, we haven't really touched on scheduling, of course, but with our scheduling module, that's kind of one of the key benefits of getting those standard times, that analysis of how you're performing standard times, because that can obviously be then fed back in through your scheduling system to then start refining that. And hopefully you'll see it improving and the accuracy improving in your schedule as well.
So one of the reports Jamie mentioned, that the plan versus actual report, you would tend to run that, and maybe review it over a period of time, not just because you've had one machine and one job that was performing particularly well with a really good operator, but you might look at what your actual setup time and cycle time is on a particular product or group of products, maybe over a 3-month period, and then make an informed decision whether you need to modify that in your ERP. And as Jamie says, if you've got our scheduler or any other scheduler in between, the scheduling system can only be as accurate as the accuracy in your standard times.
Okay. So yes, as John said, we're happy to stay on for anybody that wants to have a more direct one-to-one chat. I'll stop the recording in a moment. It's been a pleasure to have you all here today. I hope you found it useful. I will send out everything after the session. I just need a time to get things uploaded, but so bear with me. You'll hear me from me within the next day. If you want to come back to me with any questions, or we can set up any follow-up calls. As John said, this wasn't a full demo today. We're happy to do a fuller demo for anybody that wants it. I can organise all of that for you as well, so it's not a problem. That's it from us, I think.
You're free to go. Jamie and I will just wait until
We'll
you've all
wait.
gone, in case then we'll just talk to
We'll do
ourselves.
this.
So yeah,
We'll
thank
speak
you
up
all very
after.
much.